Yeah. Well, data queues is it's a thing that is newer, and it's like it's an initiative.
Yes.
That has some databases and
yeah.
snowplow data. Yeah, Sam set it up.
Yeah, it's really cool. Actually, I've been trying to meet with Sam for a while, so it's very easy.
Yeah.
I don't know. I think it would be cool.
All right. Well, I don't know who's gonna get here before 6. I think generally OpenHack, you can show up at 6, but you can also show up at 6:30. So if we need a little more time, we can take the time. Hopefully the stream is working. Do you think people are going to CoWorks?
People might. I mean,
Say.
Well, sort of implied it, but
I mean, some people like Jim Quay, I think by the time she gets off of work and stuff. It's
Yeah,
probably
yeah.
easier for her.
Parking's also a shit show, right?
Yeah,
okay.
that's true.
You work at Density, right?
Yeah,
So they're doing like some block party outside.
yeah, yeah. They're right
Yeah,
next
so
to our
it's kinda
window,
like-
and it's very loud.
Yeah.
It's like a huge band.
Yeah.
What is there an event? Why are they?
Rock
I
the
think
block.
Marriott's doing like a block
The
party.
TCG.
Yeah, TCG. Whatever it is, it's in my parking.
Yeah, it's like, oh, I'll park in the front because then we'll walk back all
Yeah, I
the way
always
there.
park.
And then like it was blocked up. So for a moment I was like confused. Wait, what's going on? And I had to come back around. Yeah. But it's not so easy with all the traffic.
So, Dana, what's your capstone project subject? I'm trying to recall these, and because we're going to work on the data models for these today a little bit.
Okay, so I'm bus tracker app, improved bus tracker app for Central.
Okay. What is tracking there? Is it like times and stops?
Like Uber for buses. Instead
Okay.
of if you have 7,000 people time, where the user would put the address of their car, where they're looking to go, and then they would be matched up to the bus or buses that would take them to their destination. I also wanted the app to send an alarm to the user when the bus was within 5 minutes of reaching the nearest person.
Okay.
So that's my dream. How far I get with that.
Yeah. I mean, that's something that let's see. How do I describe that? I'll say Uber for Centro, which is sort of gets to a little bit of it, but yeah, that's going to be interesting. So the data that you're going to be working with is there's a lot of it, and it's got GPS and things like that. Yeah. Yeah.
I already have the API manual from Central. They've already sent that to me.
Okay. And so Centro's API, you can just pull as often as you want and get locations of each bus. Is that
Pretty much, yeah.
cool?
So I have like I had it in my mind the different views, and I started working on the front end.
Okay.
For it. Oh, and then there's already something like it that's already been done for the bus tracking. The only thing is that I need to figure out how to use Xcode as an emulator because I don't have an iOS device that they built their app for iOS device.
The Utica did. Okay.
So I don't know if you'd be able to help me with that.
Yeah, it should, it should come with a simulator. Is there an open source project? Because if if it's something that's made by a contractor, they might not actually put the project on like GitHub or something, which
It
is,
was made by a bunch of students.
okay. Do you know what it's called?
And they do have a GitHub account. It's called the Utica Bus Tracker.
Okay.
I can send you the information that I have because I think Jesse or Jason, they were the ones that told me about it.
Okay. Okay, well, Mad Bus, maybe. Yeah, this looks like a web page. All right, we'll look into that. But you could probably get started right now on modeling the data that you're going to use, which a lot of people, so what ends up happening is a lot of times when people imagine a product or something that's going to go on the internet and it's going to have users, and the users are human, it's a consumer product, it's for people to use, one of the cores of your data is going to be user. It's going to be sort of storing everything associated with a certain person who's going to interact with it. So I think that's true of everybody. I mean, you have many kinds of users. You're going to have providers and customers. Kate, you're going to have obviously future adopters or whatever you call them.
And rescue agents.
Yeah.
What is your project, people?
The cleaning
Oh,
and
the cleaning.
room service.
Okay. When you said adoption, I was thinking pets.
Yep.
Yeah.
Kate is dog only dogs or
I'm
Only
going
dogs.
only dogs because I got to slow down a little bit.
yeah.
But
Yeah.
cats,
Cats are different.
Nobody cares what, and
Cats are
cats
just-
don't care either.
I mean, there are cat breed people who must
Yeah.
be wildly insane because dog breed people,
Yeah,
crazy.
yeah,
So I can only imagine what goes on the cat side, but
yeah.
that would be an interesting Christopher Guest movie. He did the dog one, he should do the cat one. But yeah, that would be. So yeah, I always read up like in the litter, how they're supposed to behave and stuff. Like I read a lot about dogs, and then I go and they just like hear this smell. I'm like,
Yeah.
okay, thanks. And I just go. The only one who exercises any discretion is my other dog. She was the one that had to get the okay to Riley.
Yeah.
Wes, are you familiar with Firebase?
Yes. Firebase is like,
I was told I needed it.
you may want to use that because it replaces a lot of the setup and the concerns that you need to bring to administering and setting up all that stuff we did with Docker and the database and stuff. You can skip a lot of that if you're basically renting it from Firebase. Now you end up getting locked into one product, and then they can charge you. It's probably more expensive or something, but it should not matter for what you're working on right now.
Okay, so Firebase.
Yeah, it's owned by somebody. I don't know if it's owned by Google or one of the big companies, but it's like a database that's basically ready to use, and you don't have to worry about where is it running or what's the server or whatever. You just sign up for it, and they give you something to connect to, and they give you the tools to connect from JavaScript and everything. So it's actually very easy to get started with. So if you
Because I'm connected to it, I'm just not sure what I'm connected to.
okay, yeah. I'm gonna have to actually read up a little bit on it, whether how it fits in with the relational model versus. I think it does all of that, but yeah.
Because if I'm gonna have to pay for it, I'd probably rather go with free. But if I'm, just paying.
Your
if I'm
time
paying
is
a little bit,
yeah, and your time is worth money too. Like
that is true.
yeah.
That's true.
Okay. So let's go through a quick exercise here before everybody. We're going to try to basically get our database models started so that we have some baseline for what our applications, what our are going to. And in order to do this, I'm just going to draw on my piece of paper here. You don't have to follow along with what I'm drawing. If you don't want, you could try sketching things out for your project instead. But basically, and I'm going to have to sort of do this upside down and then flip it. So, did everybody do the reading last night? Is there? So there is a this kind of diagram we're going to be using, which is pretty standard. Some form of this is used almost everywhere. It's called an entity relationship diagram, and it's really comes down to the important parts of this. Now, there's a whole lot of like. I think I am. I'm not on YouTube. Oh man. Technical difficulties. It says live on custom streaming service. Who's,
She doesn't see anything.
oh. Yeah. There's nothing on YouTube. That's great.
Yeah, I have the one from yesterday.
Usually the people think it's
Yeah, like the little red thing that'll say live. Yeah, that has
Hey, Alice, I can't figure out how to get on YouTube. I don't think we're online, and it's not working. I don't have a lot of time here. So it says live right here. What does that mean? Live on custom streaming service. Stop live stream.
it's not showing up for us.
Let's try it again. I know there's a short delay, but it shouldn't be more than a couple minutes, right?
Yeah.
Do I need to share, maybe? Oh, am I not? Is that? Maybe it only starts if I'm sharing my desktop, or?
It's worth a shot. I personally have not used this before. I know Zoom, but YouTube.
It does. Well, I don't know what I should do. If I should sit here and wait for it to come online, or this is fun.
Is there a way to force it to go online?
That would be nice.
Well, does the Zoom record?
Zoom is recording, yeah.
Well, if Zoom records, don't they have to render it to put it on YouTube?
I don't.
They don't?
I think if you do live stream, you just have to make.
Yeah, but as long as they have a recording, they can put it up later.
Okay, well, maybe I'll try to, yeah.
If you want to send this something up in Slack.
Yeah. Pause recording. It's recording. You know, I think, all right, copy streaming. No, that's the YouTube link. Invite. Copy URL. Okay, well, there's the hey, Kelly.
Kelly!
All right, well, I guess everybody can use this. If you can
Sorry.
mute your,
Yep,
yeah.
yep.
All right, we don't,
Nice having options.
yeah. No. Okay. So the reading last night, and hopefully this is on YouTube. We recorded some. We'll figure it out. This is not going to be a very long section because we're going to try to get right into designing our own and go do that at OpenHack. But we learned about what's called entity relationship diagrams. Like I just started by saying, the important parts of these are really boxes and lines. And this sort of lets you get a high-level picture of when you have a database. So we were typing in create table, whatever, people or messages or whatever it was. Okay, that's fine, and you can see one table at a time, you can load the data, but trying to imagine like how the messages interact with the users, and the users might interact with a login session. Like every time someone logs in, it might have a token or something you have to put somewhere else, or pictures that people are uploading, or things that are additional to that. As soon as you start adding concepts in which relate to messages, and have all kinds of what's called cardinality. A person can have many messages, or a message can have many links in it, or many pictures in it, or something like that. Then it gets really hard to like put all of that data into a place where you can just look at it as data, have it be in any shape that makes sense. It's actually going to be links to links to links and all kinds of stuff. So this is a way to draw those kinds of relationships, and how to sort of plan the shape of data that you're going to be working with, and understand all of it at the same time. So if we were going to design a data diagram for the chat app that we were doing, it would look something like this. We would have a square that is called message. We would have another square that is called person, name, or user, whatever. We'll call it user because that's pretty common. Almost everybody's going to have some concept of message, or sorry, everyone's going to have some concept of user. If they're sending each other messages, a lot of apps turn into some kind of messenger with a whole lot of other features. I mean, you're probably going to want the dog network people, when they're, doing the activities, you want them to be able to contact each other. Now you could get away with giving, just listing someone's email and saying use email, but you might end up with a message. These are both going to be very common types of data that any kind of social network or server-based community is going to use. I forgot, I have some blank paper. Does anyone else want? You want paper?
I have
Okay.
paper.
You good? Okay, so now we have messages and we have users, and the important stuff starts to happen with this kind of diagram when you want to say how are they related to each other. So this is, in the reading, this was called cardinality, and this is really the other very important part of this kind of practice. You want to say that every message is attributed to exactly one user. Every message was written by one person, but one user can write many messages at different times. So you're going to draw some kind of link between these two. But depending on the notation, and I think I like the one where it's a diamond in the middle. That eraser doesn't work at all. Now you can choose, a notation you like, and I every time I do one of these, it's a different one. So this one's kind of nice though. It's like inside this link between the two tables, you have like a little diamond here, and you're going to write. Sorry, I will flip this around. Let's say write, and this is sort of the action, or some way to describe the relationship between the user and the message. the tricky part about this one is you don't know whether a message writes
or whether a user writes a message unless you think about it.
user writes a message unless you think about it and you're like, yeah, a user writes a message.
On either side of
But
it,
on either side of it,
one
you're going to have a 1
for user because
for user because every message
is exactly one user.
is attributed to exactly one user. And you're going to have n. Is that? No, that's a backwards n. There's it just on the camera. I think I'm
I have the
Yeah,
camera.
the camera's just flipping everything, yeah.
You have to
flipping
move
everything
your
around.
mouse.
Yeah.
Oh boy.
Just move your mouse, yeah.
Well,
Know
everything.
how to flip this.
So you can flip the video or something, but
Yeah, don't know how to do that. Let's see.
we have some number of messages, and each message is traceable, attributable to exactly one user. So this, notice how this doesn't actually tell you what data in the tables, user or message. And as we showed yesterday, when we created a sample message table, there were 3 fields. One of them was the name of the person writing it.
Mhm.
One of them was the text, and one of them was the timestamp. Let's start with the text and timestamp because those are pretty straightforward. Okay, that says text backwards. It says time. Okay. So those are just data. Those are every message can have different text. Every message can have different time. But the one that's going to be different here once we start to move into this kind of a model is the user, is the name, because in our old the way that we built it with Express and the way that we made a sample table was that name was just some text. It was just Gus or Ava or whatever, and that is not really a good way to scale out a large model of data. You don't want to say every time there's a message, this was, and you want to save the string EVA as the author of that message. That's not going to help you that much. First reason is because there could be many people with the same name, of course. They're not necessarily going to have the same email. So you could maybe get away with like saying, okay, their email address, and then that's pretty much got to be the same person. Okay, but the second problem is that you're going to be duplicating that whole string, their whole name. If they have a very long name, you're going to be making many, many, many copies of the same name. And if they ever say, okay, I'm actually changing my username, or I'm legally changing my name, or something like that, you're going to have to go through and update every single one of the messages they've ever written because their name is now different. And that's going to be a very expensive and difficult thing to manage when you have a large database with a lot of users and a lot of messages. Yes. So given that, so in this case, it's one of the first cases where there's a very clear reason to say each user should have just some kind of arbitrary identifier. And it, yeah, and it could be 1, 2, 3. It could be a string of random characters.
Just as long as it's unique.
As long as it's unique, and as long as no matter what a user decides to do with their own account, it never has to change. Right? So a user has no connection to the ID. Or if they have no connection to the ID, then they can say, okay, I'm migrating all my email. I have a new email address, and you don't have to update anything except their email. The same way they can change their name, they could change their address and phone number if they have more data that's associated with them. So every table here is gonna, in general, unless you know better, unless you know what you're doing better, then meeting unless you're like, I know I don't need this because of, we'll talk about one reason why. Every table pretty much should have an arbitrary, unique ID. It's something called a primary key. So whatever you choose to be the unique identifier on your table, if it has, and it really pretty much should, it's called a primary key, and it's basically something that is used to uniquely identify every single record in that table. So a message is going to have an ID, which is just a number or string or whatever, and user will have an ID. And both of those are essentially meaningless, except for as far as they help us organize the data. The last thing, though, how do we know which message or which user each message is written by? The way that you do this is cool. Yeah. How do we know which user each message was written by? And the way we do this is by basically saying that this line here, this relationship, we're going to represent by giving every single message a user ID. Okay. This is a better way to write on a whiteboard or something, but anyway, this here is going to match the ID value of one unknown user. And then, again, because that user, sorry, feedback jamming my brain. Okay. Because that ID is completely arbitrary, completely unrelated to anything the user has an interest in, if they decide to say, oh, I'm going to put a new email, just imagine that says email, or I'm going to put a new address or a new name or whatever, that ID is never going to have to change. So all of these user IDs that link the messages to the logical, each record in the user table don't have to change either.
Question?
Yes.
So I can't read what you have in the triangle. Does that, I mean, not the triangle, the diamond in the middle, does that say relationship?
It says rights.
Oh, it says rights. Okay.
Yeah. And there's a couple, like one of the methods, one of the ways of notation is to actually have two terms, one on either side of this. So you'd say rights or rights. I'm not sure if this is correct or backward. Writes end messages and is written by one user. You have your active and your passive kind of voicings of the same thing. And then if you read it across, you could say one user writes end messages, or one message or a message is written by one user. So like the different notations are basically ways to be able to draw them visually and then be able to look at them and kind of have a prompt of how you're supposed to read them. Now, the one I've actually used most of the time is none of this. There's no words and there's no diamonds, and it's actually much easier to draw, but you have to think about it a little when you're looking at it. So it's just like a straight line here.
That means there's one.
One, yeah. And then a little, what's called a crow's foot here. So this branches out to many messages. And that's pretty intuitive. So that's what is called a many-to-one relationship. There's many messages to one user. Yes, it goes both ways. Yes. But in either case, every time you have a message, you know you can follow a single user ID to the exactly one who is the author of that exact one. And if you use the author, look at one user. And if you don't have any message ID to follow, because there could be many messages that all have that same user ID, and that's why what's called the foreign key is stored over on the message here, because each one can have the same user ID.
but it can be many of them having the same value there, right?
Did you say at one point that you assign a unique number to every message or just to the user? Because I got a little confused there.
You probably want to assign a unique ID to everything.
To both, okay.
Unless you know a reason, you know why you don't
Okay.
want to. And I guess we'll talk about that case a little bit, but I would say definitely don't bother right now.
Okay.
There is no real downside to it. It's just a little bit extra computer work, and you know, computers are fast. So, but yes, these are both unique to, you know, these are unique. Every user has its own ID, and every message has its own ID, and they're totally unique. Okay, so there's another, like you can have a one-to-one. So if we put a message ID on the user table, right, and a user ID on the message table, then it's like, well, the user only ever points to one message, and the message only ever points to one user, and hopefully they match, right? I mean, if they don't match, then you've got some consistency problems. But you could model that and say, you know, there's a user and they have, I don't know, something that a person would only ever have one of. That's the tricky thing, is they're not that common when you're modeling data, because if they only have one name or one email at a time, why aren't those fields just right in the user data, right in the user table? And there might be one or two reasons to say some users have it, some don't, but in any case, that's not as common. It's much more common to see many of something to one of something. And then there's one more kind of relationship that we'd probably expect to see more than you might want, because this one can get a little confusing. And this is the many-to-many. So let's say we're modeling a different problem here. This would be like a classroom system. This would be like Blackboard or one of those. What's the one thing there was an open source one that you were using, right? It's like Blackboard, but it's like an open source version.
Oh, Moodle, Noodle.
Oh, Moodle. Yeah.
Moodle.
Yeah,
yes.
yeah. And I guess Google Classroom. I don't like that though.
Mhm.
But anyway, we're going to have, what's one thing we have in our data model for a classroom system? Yes.
Students, teachers.
Students, teachers, classes.
Right.
That's pretty much guaranteed.
But
Okay.
also like teaching assistants and stuff.
Yes. Now there could be quite a lot.
Mhm.
Okay, so we have students. I'm just going to write this right side up and then flip it around. We have teachers. We have classes. Okay, so we have 3 tables here. And I'm not going to write all the fields that are in each one, but, you know, name and name of class and all that. The relationships are what's tricky and important here. And here's the thing. A student can enroll in more than one class, right? So you could say, okay, well, each class has a student ID, and then there could be many classes that all have the same student ID. The problem is each class also has many students, right? So
Yep.
if each class has one student ID, then there's only one student in that class. That doesn't make sense, right?
Right.
So we need something, basically, we just need something in the middle. And this is like enrollment. You could call it, you can try to get fancy with like what this concept is, what this data really is. What I often do is just give up and call this student to class. And it's just student to class. This is the data that maps student to classes. It's another table. And we're going to go like this. And we're going to say each class has a student to class ID, right? So that means there's going to be one class and there are many student to class. Sorry. I have this backwards, and like I told you, it's confusing. There's one class. Let's start over here. There's one class. There's many student class mapping or enrollment or whatever. So each student class contains a class ID,
Mhm.
and let's assume everything has an ID. So student to class has a class ID, and then student to class is also going to have a student ID. And that's really all that it has to have. So if you look here, you get these crow's feet here on both students and classes. And this table in the middle is just a way for you to be able to say many classes each have many students.
Mhm.
You're going to end up with more of these than either students or classes. And they don't really have a good, the noun for this is enrollment or whatever it is when a person enrolls in a class, right?
Is there another way to do the diagrams? Because with this being transposed like this, it is.
Difficult. Yes. So there is, and why don't we just switch to that, and then let's go to OpenBank. The way to do that is a thing called a drawing tool. One that we use at work is at draw.io.
Perfect.
And you have to, like, the first time you have to register to say, like, whether you want to start an account or whatever. I just set up device, which means I can save them on my local machine.
Mhm.
But eventually they'll let you create a new diagram. And, I don't know if they have, like, database specific stuff. Some other stuff like Visio and Lucidchart, where that article was, they have specific, database examples.
Yeah.
This one you kind of are a little bit on your own, but I usually start with, like, a flow chart or just blank. And you can drag shapes.
Why am I up on the screen?
What?
I was like, why am I up on the screen? I didn't know that my
Your
camera
microphone's
was on.
on, so you're coming through the, which is,
Okay. But I was like, I didn't realize that my camera was on.
It's just your sound and your computer.
Yeah.
You have to go to the Zoom call.
Yeah, I wasn't even like concerned about the microphone. I just didn't want my
there's a
I'm up
mute
there.
button
Where?
somewhere down mute, yeah.
Stop video. There we go. Yep. And then
That's me.
now it's on mute.
Okay. So this, I like doing this on my own. You're absolutely right. It's not the easiest to share with someone. It's usually good to do a draft on something like this. And then when you want to keep something and evolve it and have it in a digital format, you can do this. So this.
The only reason why I was pushing for it is because I've done data modeling, I've built a bunch of databases using Access, and this is not the easiest concept to grasp. I mean, everything is backwards and stuff. It just makes it a little tougher. I just kind of feel bad for the people who are learning this for the first time. It would help them to be able to see it accurately.
Well, so the best tool for doing this of all of them is actually something called Entity Framework. And this might be controversial among my coworkers, but it is the best tool for doing this. It's basically this kind of thing, except you draw your databases and you link them together, and then you click go, and it says, here's your database, and it makes it for you.
I also like it framework. I'm on your side.
It's the greatest.
It's really
It is the greatest, yes.
What's it called again?
Entity Framework. It's a Microsoft thing. I don't know if they have a free version yet, which is, of course,
I think it works with .NET Core now.
really, with the visual designer and everything. Community, wow.
And
Amazing.
it's okay, I just wanted to mention one other thing that helped me with modeling data, because I've dealt with a lot of student records. So instead of just saying go, and because then you're seeing that across your different redundant. So when it was the student ID, and when it was teacher ID, because then when I took different IDs, which IDs were doing what, where.
Yeah. In this example, I mean, I would have this have like class ID
Right.
and teacher ID, but yes, there is definitely an argument for having.
Something more descriptive, and then without, when you're programming, not to have the space, it would be like an underscore, because when you're programming, the space is problematic. So it would be like teacher underscore ID or student underscore ID, so.
Couldn't you just say TID and SID?
I would go like this. This is how I would actually make it.
Right.
Lowercase with an underscore and
Yeah.
full name teacher.
Okay.
Just something that creates more meaning, because as we get more and more data, just to see ID, it does start to get confusing on the.
I'm not sure. I'm not actually sure I agree with the choice of doing it everywhere, but I don't disagree. I don't think it's a bad choice. I just maybe, yeah.
When it's descriptive, you can actually, it's like, oh, that's where that's going. That's what this one is looking to do.
So an enrollment would be a class ID and a student ID, and then I don't know, what do you call it? A teacher linked to a class.
Teacher linked to a class.
Yeah, like a student taking a class, that would be like enrolling, or that's enrollment.
It would be a course.
Course offering or
Yeah.
Yeah.
Yeah. Course offering. Right, you have like a different schedule as a teacher.
Yeah, this is a lot easier to see. And there's a lot of debate about whether they should be plural or not. Just make them all the same if you want it to be student. I've heard a lot of times it's like, to make the table name singular because each record in here is one student. Yeah. And obviously each of these are going to have names and stuff. Now here I will link these up, but here's a little puzzle. What if you wanted to say, okay, let's add phone numbers or emails so people can contact each other? Well, notice how I just said people, and students and teachers are both people. So what are we going to do? I mean, do we add phone number and email to both of these tables and then have like two places where phone number lives?
Or just make like a people box.
You could make a people box.
Box, no?
You could do that. You could make a contact info box that's just contact info, or you could make, there's a lot of other ways to do it, and a lot of times all of them will actually kind of work, and some of them will be a little more awkward in different cases than others. So it gets very tricky with like finding the right, because really if you get fully abstract, it's like you don't, a legal person could be, I don't know, all kinds of
Corporation or
a corporation. Yeah, you could have a corporation enroll in a class, maybe in some absurd school where they do that. But legally, in many contexts, that's true. So if you really try to make this fully represent everything, it will become incomprehensible at a certain point. And that's a lot of this exact practice is just balancing that, is figuring out, what is the appropriate way to split apart this data so that we're not copying the same data everywhere and having a very difficult to maintain thing, but at the same time not having something that's completely incomprehensible and abstract. So that's what that's the challenge you're going to run into as soon as you start modeling the data for your capstone. It will be, in your case, are vendors, are people selling a service and people purchasing the service the same root table with like links to a seller and a buyer, or is there a contact info type of, how do you name and split and partition those concepts? That's going to be what you have to work on. Um,
I have a question.
yeah,
What if, so like for mine, if like say I'm a user, and I move, so I have to change my address, but the address changes a bunch of different data points about me as a user now.
yes.
How do you address that? Like, that's a big question, sorry.
Well, I mean, you need to start listing out what are those data
Right.
points. And probably most of them would have to be associated with that address as well as that user. So you know that because they're associated with an address that's out of date, they're not currently relevant or they're
The
historical.
association
Yes.
afterwards.
Yeah.
That makes sense.
Another thing is you might want date ranges on your resident. You know, if you had a person and an address and you were separate and you had a residence, the links them together. You might want date ranges on that because people move in and out of different addresses.
I think what normally happens though is as long as your address is on the one side of it, and if it's related to a bunch of other tables, I think what happens is when you make the change, and if you have to be somewhere else, that change will just show up on the other side because it's on the one side where it has that unique ID. And then if it has to show up many times in other places, it will just show up because you changed it where the primary ID.
No, I know, that's what I mean, but I'm trying to figure out, like, how would you, never mind.
Well, you mean if it was not part of the exact address table itself, but it was something that would follow a person from address to address. Maybe there's more than one per address or something where it can't be in the same table.
Yeah,
Okay.
so, it's okay, that's like a really loaded question right now.
Yeah. I
It's,
mean,
it sounded less complicated in my head.
yeah. You probably run into that kind of thing.
I just thought a more simple answer would be something like that should be addressed in what you're setting up, Gus, right? Which is the one to many. The one to many.
Yes, with the right, it's really hard to actually come to a conclusion though, unless we know what is this data that you're talking about. If it's completely abstract, you could reasonably think of cases where it should or it shouldn't do any of this stuff. So, I mean, a lot of it, and this is partly why I kind of want to get people started right away on just modeling this before we're actually digging into the databases at all, because a lot of this kind of stuff is going to come up as you get to the real, the nuts and bolts of how each of these models is going to work. Okay, so anyway, here's our completed diagram. It's pretty crude, but it should at least be correct. So each enrollment has a class ID which points to here and a student ID which points to here. So that effectively you can query for any enrollments with a particular class ID. You'll find all the students in that class, or you can query for all the enrollments with a particular student ID. You'll find someone's course schedule. Likewise, you'll find the teacher's class schedule and the teachers, if there's more than one teacher, if there's a TA or something. So once we get into a TA table, then you have to decide, is that a different table? Or is there a type on here, which is, adjunct or tenured or TA? And all of those fun things and more await you when you start modeling your data. I think we should head over to OpenHack right about now, and let's get right into it. We're going to go to OpenHack. The activity for today is to model your data, and also, just about as important is to ask someone for help, get some help, learn how to do that, because that's a really good skill to have. All right, see you later.